Good afternoon to one and all. So, in the previous lecture, we have discussed regarding some of the problem related to a Swinburne test. So, I think I have given one problem for homework. How many students solved that problem? I have given one problem for homework. How many students solved? Put your answer in the chat box immediately within 3 minutes, 2 to 3 minutes. All of you put your answer in the chat box. I think question is given, find the efficiency when the machine is run as a generator and when the machine is run as a motor. Put the answer in the chat box. Put the answer. What is the answer? Roll number 14. You have solved. What is the answer? Efficiency. When it is run as a generator, what is the efficiency? Generator efficiency 90.3. And next one, what about motor? 89.5. Right. So roll number 14 solve the correct answer. Is there anyone? आणखी कोणी सॉल्व केले का? Is there anyone from division A or B? Put your answer in the chat box. Okay, so no one is given a response regarding that. So we will start today problem related to Hopkinson test. Again, it is easy problem, but it is little bit lengthy. So if we go step by step for solving these types of problem, then it is easy. Now see the numericals on Hopkinson test. Do you know that? We will just give some introduction or some of the information related to Hopkinson test. So Hopkinson test, in that there are two identical machine it can be used. So on that two identical machine, one machine it can be run as a motor, one machine it can be run as a generator. Okay. See, Hopkinson test, it is also called as back-to-back test. We already discussed. In that there are two machines, two identical machine are there. One run as a motor, one run as a generator. So motor, it is run from small amount of supply. It can be taken from the supply lines. When the motor start rotating and the speed achieved by the motor, it is the rated speed. Then there is a direct coupling between the motor and generator, or direct coupling between the both two machines. The generator, it is also rotating at the same speed as that of motor. Okay, these two machines are mechanically coupled to each other, and these are electrically connected parallel to the line. Line la kasha astat, parallelly connected astat. So there are shunt field machine are used, and on that machine, if the generator start rotating according to principle of generator, it will generate some of the electricity, and this generated power, it can be fed as a back input to that of motor. Motor चे input ला काय करतो आपण, फेड करतो. So these machines are run on its individual power, little bit or small amount of power taken from the supply. So we can call it as a back-to-back test, or we can call it as a regenerative method. Okay, or it may be regenerative regeneration method, or it may be regenerative method. So all information related to that we have already discussed while discussing regarding theory. Now today we will discuss about the problem related to that. All of you write this problem. See, the Hopkinson test on two similar shunt machine gives the following full load data. Okay, the Hopkinson test, it can be conducted. Hopkinson test, it can be conducted, and after conduction of Hopkinson test, it will give a following result. It will give a following result, or it will give a following full load data. In that, the line voltage is given, that means supply line voltage, that is line voltage is given 110 volt. Line current, it is near about 48 ampere. Motor armature current, it is nothing but 230 ampere. Field current are 3 ampere and 3.5 ampere. Then resistance of each machine, it is 0.35 ohm. Brush drop of 1 volt per brush. Calculate the efficiency of each machine. प्रत्येक मशीनची आपल्याला काय करायचे, efficiency calculate करायची. Okay, so all of you write this problem. For solving this problem, we will draw the diagram, that is circuit diagram, or how it can be connected. After drawing the diagram, we are writing the given data, and then we will solve one by one. Okay, see, all of you write and write down given data. Write the problem, read the problem carefully, and write down the given data from this problem. झालं? Or
yes, sir.
okay. Solution in that given data. Okay, see, for solving this problem, if we draw the diagram of Hopkinson test, then it is very easy to solve. Okay, so see, in case of Hopkinson test, it will require two identical machine, दोन identical machine पाहिजेत. Suppose this is the machine 1, this one is the machine 2. On that machine, one machine is run as a motor, and another one machine, it can be run as a generator. त्याच्यामधली एक machine motor बनवून run होते, second one machine, it can be run as a generator. So these are the shunt machine. So shunt field winding, it can be drawn here. So here the shunt field winding of the generator, shunt field winding of the motor. Okay, now see, why it is needed to draw the diagram. That means it is useful while finding the value of current in armature as well as current in the line, or it may be field. Field मतलब current calculate करायचा असेल किंवा कोणता current येईल. So it is easy to understood. See, these two machines, line voltage is given, that means supply voltage, it can be given. So line voltage I am writing here, supply voltage or line voltage VL, it is equals to 110 volt. So we will writing given data. Line current, that means current taken from the supply, that is IL, or if in case of theory of Hopkinson test, if you have given a notation, that is I1, current I2, current I3 and I4, they use केले तरी पण चालेल. Otherwise you will use, that is IL is equals to, that means current taken from the supply, it is equals to current taken from the supply, it is equals to 48 ampere. Current taken from the supply, it is equals to 48. Motor armature current, which current is given here? Motor armature current is given. मोटरचा आर्मेचर करंट दिलेला आहे ना. मोटर आर्मेचर करंट किती दिलेला आहे? मोटरचा आर्मेचर करंट
230.
motor armature current is given, that is 230 ampere. See here, that means if we draw the diagram, it is very easy to represent the current. That means कोणता current दिलेला आहे? armature current of the motor. इथला current दिलेला आहे IA of M. I am writing armature current of motor, it is equals to 230 ampere. Field current are 3 ampere and 3.5 ampere. म्हणजे पहिल्या मशीनचा 3 ampere and second machine field current, it is equals to 3.5 ampere. That means this first machine having an armature field current of 3 ampere, याचा field current जो आहे 3 ampere आहे, and this one is the field current of second machine is nothing but 3.5 ampere, right? That means IL is equals to 48. IA of the motor, armature current of the motor, it is equals to 230 ampere. Then field current of the motor, it is equals to field current of the motor, it is equals to 3 ampere. 3 ampere. Field current of the motor, it is equals to 3 ampere. Field current of the generator, it is equals to 3.5 ampere. Again, the resistance of each machine is given, that is armature resistance of each machine. प्रत्येक मशीनचा armature resistance दिलेला आहे. That means either RA of motor or it may be generator. RA दोन्ही मशीनचा. Each machine having an armature resistance of 0.035. 0.035 ohm. So that means मोटरचा पण 0.035 असेल. Generator, it is having an armature resistance of 0.035. Okay. Now brush drop of 1 volt. Brush drop of 1 volt is given. Brush drop of 1 volt, it can be given, that is brush drop दिलेला आहे. It is nearly equal to that of 1 volt. Brush drop, it is equals to 1 volt. And calculate the efficiency of the each machine. प्रत्येक मशीनची काय करायचे? Efficiency calculate करायची. Okay. So brush drop, it is equals to 1 volt per brush. So there are 2 brushes in case of one machine. So 2 volt per machine. All of you understood that. Okay. See, what are the given data दिलेले आहे आपण write down करून घेतलेले आहे. That means this quantity are given. BL is given. Then armature current of the motor is given. Then field current of the motor and generator, it is also given. And the line current is given. Line current is 48. Okay. Now you people know the value of armature current. You know the value of shunt field winding current. Whether you are able to calculate the value of this current? Calculate करू शकतो का? Supply current of the motor. Suppose supply current of the motor, if both machines are run as a Hopkinsons, or both machines are running as a back-to-back, then we are calculating the supply current taken by the motor. मोटरने घेतलेला सप्लाय करंट किती असेल? Hello, please give me reply.
230 plus 3.
230 plus 3, that means if we make sum, outgoing is equals to incoming, that means incoming current is equals to sum of outgoing current. So it is nothing but this current we will got 233. Okay, now see, the supply current taken from the machine, taken by the motor, it is nothing but 233, and we are having the value of line current. Whether you people able to calculate the value of output current of the generator, हा करंट मी कॅल्क्युलेट करू शकतो का? सो दिस करंट म्हणजे काय आहे? ह्या जनरेटरचा आउटपुट आहे, दॅट मीन्स आउटपुट करंट ऑफ द जनरेटर करू शकतो. हॅलो, give me reply immediately whether I am able to calculate this current. Hello, see again, here it is nodal point, sum of incoming current is equals to sum of outgoing current, or we can write the KCL equation, that is summation of all the current meeting at a junction point, it is equals to 0. याच्यावरून हा आउटगोइंग करंट 233 आहे, this one is the incoming current 48, this one is the incoming current, that means outgoing is equals to incoming. So suppose I am representing, this is the output current of the generator, ILG I am representing. So I am able to calculate the value of ILG. ILG it is equals to IL of motor minus current taken from the supply lines. So IL of motor, that is 233, minus current taken from the supply line, it is nothing but 48. किती value? So first of all, this current finding, it is very important, then we are able to calculate the efficiency. जोपर्यंत हे करंट निघत नाहीये तोपर्यंत आपण efficiency calculate करू शकत नाही, because you know the value of all each and every current for finding the losses. किती value? 233 minus 48,
185.
185. Okay, so that is output current of the generator, it is nothing but 185 ampere. बघा आता मी काय केलं बघा, स्टार्टिंग पासून हे रिप्रेझेंट करून घेतलं, दिलेल्या व्हॅल्यू रिप्रेझेंट केल्या, हे दोन करंट मला माहित होते, त्याच्यावरून हा करंट कॅल्क्युलेट केला. If I know the value of this current and this current, then I am able to calculate the value of this current. Now I want to calculate the armature current of the generator. मला जनरेटरचा आर्मेचर करंट कॅल्क्युलेट करायचा आहे. बघा, हा आउटगोइंग करंट, this one is the outgoing current, is nothing but 185. This one is again outgoing current, it is nothing but 3.5, and this one is the incoming current to that of node. Then I am able to calculate the armature current of the generator, IAG. IAG calculate करू शकतो का मी? IAG it is equals to किती येईल? Again summation of all the current meeting at a junction point, it is equals to 0, or sum of incoming current is equals to sum of outgoing current. इनकमिंग किती आहेत? एकच आहे, आउटगोइंग दोन आहेत. सो समेशन ऑफ इनकमिंग इज इक्वल्स टू आउटगोइंग. मला आयएजी कॅल्क्युलेट करायचं आहे, किती येईल आयएजी? लक्ष देते का तुमच्या? कॅन आय एक्सप्लेन वन्स अगेन? हॅलो, give me reply.
Yes, sir.
A division people, you have already studied regarding that, can give me reply. So I want to calculate the armature current of the generator, जनरेटरचा मला आर्मेचर करंट काढायचा आहे. सो वेदर दिस इज द सम ऑफ दिस टू करंट और सबस्ट्रॅक्शन ऑफ दिस टू करंट. या दोन करंटचे ऍडिशन होईल का सबस्ट्रॅक्शन? इनकमिंग करंट इज इक्वल टू आउटगोइंग करंट. हा इनकमिंग आहे, हे दोन आउटगोइंग आहेत. सो दॅट मीन्स IAG इट इज इक्वल टू both outgoing current summation 185 plus 3.5. So it is equals to 188.5 ampere. It is the armature current of the generator. हा काय आहे? जनरेटरचा आर्मेचर करंट. So this value here represented all. बघा आपल्याकडे एवढ्या करंटच्या व्हॅल्यू नाहीयेत, आपण डायग्राम वरून किंवा याच्यावरून कॅल्क्युलेट केले. सो दिस इज फर्स्ट स्टेप to solve the problem related to Hopkinson test. Hopkinson test चे प्रॉब्लेम सॉल्व करताना जे दिलेले करंट आहेत, कारण मला IA ऑफ मोटर माहित पाहिजे. ऑल्सो आय वॉन्ट IA ऑफ जनरेटर बिकॉज आय वॉन्ट टू कॅल्क्युलेट द कॉपर लॉसेस. मला कॉपर लॉसेस कॅल्क्युलेट करण्यासाठी आर्मेचर करंट काय पाहिजे माहित पाहिजे. ओके, once we have calculated armature current of both the machine, then we are able to calculate the copper loss of each machine. Then we are calculating the efficiency. Now see, first one step is that as a motor, or we will take first details or calculate first details of motor details. See the armature copper loss of the motor. Armature copper loss of motor. मोटरच्या आर्मेचरचे कॉपर लॉस. व्हॉट इज द फॉर्म्युला? फॉर्म्युला काय? व्हॉट इज द फॉर्म्युला फॉर कॉपर लॉस?
I square A into RA.
Okay, IA square RA, that is IA square RA, where IA is nothing but armature current of the motor and RA is nothing but resistance. Now what is the value of IA? IA ची व्हॅल्यू काय?
230.
230. That is armature current of the motor. It is nothing but 230. 230 square into armature resistance, that is 0.035. किती येते व्हॅल्यू बघा? कॉपर लॉस ऑफ द मोटर
1851.5.
1851.5 watt. Okay, now मोटरचे कॉपर लॉस कॅल्क्युलेट केले. सिमिलरली वी आर कॅल्क्युलेटिंग द कॉपर लॉसेस ऑफ द फील्ड वाइंडिंग. मोटर शंट फील्ड वाइंडिंग, मोटरची शंट फील्ड वाइंडिंग आहे इथं, याचे कॉपर लॉसेस कॅल्क्युलेट करा. सो कॉपर लॉस ऑफ मोटर शंट फील्ड वाइंडिंग, शंट फील्ड वाइंडिंग. ओके, अगेन फॉर्म्युला काय? फॉर्म्युला कॉपर लॉसेसचा इन केस ऑफ फील्ड वाइंडिंग. कॉपर लॉसचा फॉर्म्युला असतो I स्क्वेअर R. कशामधले कॅल्क्युलेट करतोय आपण? आर्मेचर मधले करत असेल तर आर्मेचर करंट घेणार. मी जर शंट फील्ड वाइंडिंग मधून शंट फील्ड वाइंडिंगचे कॉपर लॉसेस कॅल्क्युलेट करत असेल तर मी शंट फील्डचा करंट घेणार. दॅट मीन्स ISH स्क्वेअर इंटू RSH. ओके, सी फॉर्म्युला that is ISH square into RSH. You people don't know the value of RSH, so instead of writing RSH, I am able to write V divided by I. Okay, so that means V divided by I जर मी पुट केलं तर I will get the value V into ISH, or I am getting the formula V into ISH. V divided by ISH जर पुट केलं तर याच्यामधला एक ISH आणि हा एक ISH कॅन्सल होईल. ओनली वन ISH इट कॅन बी रिमेनिंग. सो V into ISH. वेदर यू पीपल हॅव्हिंग द व्हॅल्यू ऑफ व्होल्टेज V, व्होल्टेजची व्हॅल्यू आहे का आपल्याकडे?
Yes, sir.
व्होल्टेज इट इज नथिंग बट लाईन व्होल्टेज, पॅरलली कनेक्टेड आहे. सो दॅट 110 into RSH, सॉरी ISH into V. ISH ची व्हॅल्यू किती 3. So 110 into 3. It is nothing but 330 watt. This is the copper loss. Okay. Now again brush drop is given here. Brush drop, it can be given. Brush drop दिलेला आहे. So 1 volt per brush. 1 volt per brush. Okay. So 1 volt per brush म्हटलेलं आहे. So there are 2 brushes, so that 2 volt per machine drop in, that is voltage drop, into current taken by that brush or it may be armature. किती येईल 2 volt voltage आहे, करंट त्याच्यामधून किती फ्लो होतो ब्रश मधून, whether it is 3 ampere or 230 ampere.
230.
Brush it will carry a current as same as that of armature current. That means it is 230. So it is equals to 460 watt. Okay. See, you have calculated the copper losses in case of motor. Motor चे all copper losses calculate केले. त्याच्यामध्ये armature copper loss, shunt field winding copper loss, also brush drop is given, so that brush copper losses we have already calculated, or brush losses it can be calculated. See, so total losses of the motor. Can I rub this given data? इकडे लिहिलेलं रब करू का मी?
Yes.
Okay, I will rub this all. I hope you all are written this. Okay, see the total losses of the motor. Step by step जायचे याच्यामध्ये. Total losses of motor, it is equals to sum of all the losses. Yes, losses ची sum 1851.5 plus 330 plus 460. It is nothing but total losses of the motor. That is total variable losses of the motor. Motor चे total variable losses. किती आहे ती व्हॅल्यू?
300.
300. 18 3 21 4 25 नियर अबाउट 26 26 यायला पाहिजे. 23 कसं येईल? Hmm. 2600.
41.5.
0.5 watt. 2641.5 watt. So we have calculated the total losses of the motor. Now similarly calculate the losses of the generator. So right here for generator, these are the variable losses. आपण जे calculate केलेले ते variable losses. See, for generator again same armature copper loss of the generator formula IA square RA. So IA generator चा armature current किती आहे? What is the armature current of the generator? Armature current of the generator. बघा डायग्राम मध्ये बघा, त्यासाठी तर मी डायग्राम ठेवली समोर. हॅलो
188.5.
188.5. This is the armature current, this is the shunt field current, this one is the output current or load current. So it is equals to IA square 188.50 square of that into RA, armature resistance both machines are same दिलेला आहे, so it is nothing but 0.035. किती येते व्हॅल्यू? आर्मेचर कॉपर लॉस ऑफ द जनरेटर
One two four 3.62.
1 2
43.
okay 1 2
.62.
66
62.
62, so it is near about 1244. Okay, 1244 watt. It is the armature copper loss of the generator. Now similarly, we are able to calculate the shunt field copper loss of the generator. Shunt field winding madhun flow होणारा current, that is 3.5 ampere into resistance you don't know, so that V divided by I, V into IL, so V is nothing but 110. It is nothing but copper loss of the generator. हे झाले जनरेटरचे कॉपर लॉस. सांगा किती येत आहेत?
385.
385. Okay, so 385 watt. So this is the shunt copper loss of the generator. Again, brush drop of the machine is given, that means brush losses is there. So brush loss, 2 volt brush and armature current, it is nothing but 188.5. So it is equals to किती येईल?
377.
377 watt. Okay, now total losses of generator चे total losses किती येत आहेत? Sum of all the losses, armature copper loss, field winding copper loss and brush loss. करा summation of all these three, sum of all the three, 1244 plus 385 plus 377 किती येईल?
4262.5.
4262.5. या तिन्हीचे ऍडिशन करायचे. कॉपर लॉस, आर्मेचर कॉपर लॉस, शंट कॉपर लॉस
2006. 2006.
2006 no, 2006 watt. It is nothing but total losses of the generator, that is total copper loss of the generator. बघा फर्स्ट स्टेप मी काय केलं, करंट कॅल्क्युलेट केले. त्याच्यानंतर सेकंड स्टेप इज दॅट फॉर कन्सिडरिंग वन मशीन we are calculating the variable losses of that machine. Considering second machine, we are calculating the variable losses of that machine. Now see, we want to calculate the constant losses. आपल्याला काय करायचे? Constant losses calculate करायचे. Then we are able to calculate the efficiency. So for calculating the constant losses, we want to take both the set of this machine, that means combining these two machines. So I am writing here for a set of motor and generator, that is mg set. See, total copper losses of mg set किती येतील? total copper losses of mg set, sum of these two losses, या losses ची, suppose this is equation 1, this is equation 2. These two losses is nothing but copper losses of individual machine. So if we take the sum of these two, it is nothing but total copper losses of the both the set, दोन्ही सेटचे copper loss. ओके, म्हणजे मोटर जनरेटर सेटचे कॉपर लॉसेस. ऍडिशन ऑफ दिस टू, दॅट इज टोटल कॉपर लॉस ऑफ द एमजी सेट. किती येतील? 2641.5 प्लस 2006.
4647.5.
ओके, 46 किती येत आहेत?
47.5.
4647.5 watt. It is the total which losses? Copper losses na? Hello, these are the copper
Yes, sir.
losses of mg set.
Yes.
Okay,
Yes.
now
Yes, sir.
see in Hopkinson test, we are putting one of the switch here. एक आपण switch put करत होतो. Okay, right? No, that means here it is एक switch होता. Before closing that switch, there is a open in the secondary of the generator. That means there is a current flowing from that is nothing but 0. So at that situation, we can call it as a machine. It can be running on no load condition, right? बरोबर ना? स्विच ज्या वेळेस ओपन होतं, म्हणजे जनरेटरचा ज्यावेळेस स्विच आपण क्लोज करत नाहीये, at that situation the machine it can be running on no load condition, and the power taken at the no load condition, it is nothing but it is used to overcome the only losses, that is no load losses. So according to this, we are able to calculate the no load losses, current taken from the supply, and the voltage at the no load condition. It is nothing but no load power taken by the machine at a no load condition. See, the input power or P input taken at no load condition. P input taken at no load condition, it is nothing but terminal voltage V into current taken from the supply. So it is equals to 110. हा करंट त्यावेळेस कोणता घेते? हा करंट ज्यावेळेस 0 आहे, इकडून फ्लो होणारा करंट 0 आहे. ओनली दिस 48 एम्पियर करंट इट विल बी फ्लोइंग फ्रॉम मोटर, राइट? बरोबर ना? सो दिस इज नथिंग बट नो लोड पॉवर टेकन बाय द मोटर ने घेतलेली नो लोड पॉवर. सो जस्ट कॅल्क्युलेट द पॉवर टेकन ऍट नो लोड कंडिशन. 110 into 48 किती येईल? किती?
5280.
5280 watt. Okay, now this is the no load power taken from the supply. If I subtract copper losses from this no load power, then I am able to calculate the constant losses. So the constant losses of the machine, or we can call it as a iron or friction losses, constant losses, it is equals to no load power taken 5280 minus copper loss of both the machine 4647.5. किती येत आहेत कॉन्स्टंट लॉसेस? सबस्ट्रॅक्शन करा. अ
604.5.
604.5280 minus 4647.5. बरोबर आहे का? फोर 4647 आहे. टेन minus 7, it is near about 3. Can I use calculator?
$632.5.
कसं करताय कॅल्क्युलेशन 4647.5 so 632.5 you are doing a little mistake so 632.5 it is the constant losses 632.5 watt it is the constant losses. Okay, so see whether these constant losses for individual machine or it may be both mg set. Can anyone tell? हे जे constant losses आले 632.5 whether it is for each machine or total mg set. हॅलो, लॉसेस कोणते मायनस केलेत आपण? एका मशीनचे केले का बोथ मशीनचे?
both machines.
हाँ, बोथ मशीनचे केले. Power taken at the no load condition, so both machine it will be take because there is a direct coupling. Generator run करण्यासाठी पण मोटर काहीतरी power घेते, so that these losses came for both machine or mg set. Okay, so if we want to calculate the constant losses at individual machine, just divide by 2. चला divide by 2 करा. That means I will rub here this side. See, constant losses of each machine or individual machine. Constant losses of individual machine. It is equals to constant losses of both the machine 632.5. There are two machines, so that divided by 2. It is nothing but constant losses of individual machine. किती आता इथे 316 वॅट. ओके, बघा काय केलं आपण प्रोसिजर नुसार. ओनली वी हॅव कॅल्क्युलेटेड द लॉसेस, दॅट इज कॉन्स्टंट लॉस ऑफ ईच मशीन and variable losses of also each machine. आपल्याकडे लॉसेस आहेत. नाउ वी आर एबल टू कॅल्क्युलेट द इफिशियन्सी. आता आपण इफिशियन्सी काय करू शकतो? कॅल्क्युलेट करू शकतो. सो सी, राइट फॉर दॅट मोटर इफिशियन्सी. कॅन आय रब दिस? ही साइड रब करू का मी? लेफ्ट हँड साइड.
Yes, sir.
ओके, see, first of all we will calculate the motor efficiency. So motor efficiency, okay. See, we are having the current, that is motor input current, you people know. Supply voltage of the motor, you people know. According to this we are able to calculate the input power, and you people know the losses, then we are able to calculate the output power also. Okay, see, power input of the motor, what is the formula? P in input power of the motor. What is the formula for input power of the motor? Power input म्हणजे मोटर न घेतलेला करंट, V into I. Supply voltage V is nothing but 110. Current taken by the motor when Hopkinson test it can be done. कोणती करंटची व्हॅल्यू आहे? कोणता करंट घेणार आता याच्यामध्ये? इनपुट करंट ऑफ द मोटर. मोटरचं इनपुट करंट किती आहे? 233. So don't be confused, because ज्यावेळेस स्विच क्लोज करतोय त्यावेळेस मोटर जनरेटरचा आउटपुट पण घेते. म्हणजे हा करंट आणि सप्लाय कडून घेतलेला करंट या दोन्हीचे ऍडिशन जो होऊन जो करंट आलेला आहे, इट इज नथिंग बट इनपुट करंट ऑफ द मोटर. सो इट इज नथिंग बट 233. कन्फ्युजन करून घेऊ नका. बघा So this is 233 ampere. It is the input current of the motor. Calculate the power, input power.
Two five six three zero.
25630 watt. Okay. 25630 watt input power आपण calculate केली. You people know the value of losses of motor as well as losses of generator. मोटरचे इंडिव्हिज्युअल लॉसेस, कॉन्स्टंट लॉसेस पण माहित आहेत. मोटरचे इंडिव्हिज्युअल कॉपर लॉसेस पण माहित आहेत. जनरेटरचे इंडिव्हिज्युअल कॉपर लॉसेस माहित आहेत. जनरेटरचे इंडिव्हिज्युअल कॉन्स्टंट लॉसेस माहित. सो टोटल लॉसेस ऑफ द मोटर, टोटल लॉसेस ऑफ मोटर किती आहेत? कॉन्स्टंट लॉसेस ऑफ द मोटर, मोटरचे कॉन्स्टंट लॉसेस किती आहेत? 316, राइट? हेलो,
Yes, sir.
Yes,
कॉपर
sir.
लॉसेस ऑफ द मोटर, मोटरचे कॉपर लॉसेस स्टार्टिंगला कॅल्क्युलेट केलेले आपण किती आहेत? 2641 पॉइंट किती 5 ना? हेलो.
Yes, sir.
Okay, so according to this we are able to calculate the total losses of the motor. किती येत आहेत बघा हे? 316 अधिक 2641.5.
2957.5.
2957.5 watt. This is the total losses of the motor. Now we know the input power, we know the total losses. We are able to calculate the output power, that is P out of the motor. Output power of the motor, it is equals to input 25,630 minus losses of the motor 2957.5. किती येते P out, output power? किती आहे ती व्हॅल्यू?
22672.
What
22
22
67
67
2.
22672.5.
5.
It is in the watt. So you are having the value of P out, you are having the value of P in. So according to this we are able to calculate the efficiency of the motor. मोटरची efficiency calculate करू शकतो. 22,672.5 divided by 25,630 into 100. किती आहे ती efficiency बघा मोटरची? Efficiency of the motor, that is percentage efficiency of the motor. How much? How much? Just put the value in the calculator and tell me the answer.
88.47.
Okay, 88.57%.
47, sir.
47 ka? Okay. Instead of writing 47, you can write 5.5 also. Huh? 88.5% efficiency of the motor. Okay. Getting? So similarly, calculate the efficiency of another machine, because question it can be asked. Calculate the efficiency of each machine. प्रत्येक machine ची efficiency calculate करायला सांगितली, आपण motor ची calculate केली. Now similarly for generator. Generator ची calculate करताना while calculating the efficiency of the generator, you are having the output power of the generator. आपल्याकडे output power आहे generator ची. I am writing here. See, output power of the generator, P out, it is equals to, what is the output current of the generator? P into I formula आहे. Generator चा output current किती आहे? Output current of the generator, whether it is 188.5 or whether it is 185. किती output current of the generator?
188.
188.
188.5.
185.
185 येईल ना. हा आर्मेचर करंट आहे. आउटपुट साइडला टर्मिनल व्होल्टेज आउटपुट पॉवर कुठे असेल? सो दिस इज द 185. इट इज नथिंग बट आउटपुट करंट. सो 185. Always keep in mind, in case of generator, output current is less than that of armature current. In case of motor, in case of motor, current taken from the supply, or it may be input current, it is always greater than that of armature current. लक्षात ठेवा थोडंसं, कारण आपण बरेच प्रॉब्लेम सॉल्व्ह केले त्याच्यामध्ये डीसी मोटर आणि डीसी जनरेटर मध्ये. सो इफ वी कन्फ्यूज इन वन व्हॅल्यू, दॅट मीन्स पॉइंट व्हॅल्यू जरी असेल, कन्फ्युजन झालं त्याच्यामध्ये की होल प्रॉब्लेम रिमेन्स रॉंग. ओके, सो कॅल्क्युलेट दिस पॉवर आउटपुट. अगेन you are having the value of power output, and you people know the value of losses. Losses माहिती आहेत बघा, total losses of the generator. Total loss of generator, it is equals to constant loss 316 and variable loss. What is variable loss? 2006. बरोबर, 662 sons of bar. 2322 na?
Yes, sir.
It is the loss. You people know the value of output power. You people know the value of losses. According to this, you are able to calculate the input power. That is P in is equals to output power plus loss. So output power माहिती आहे तुम्हाला, 110 गुणिले 185 किती आलं? किती आले आउटपुट पॉवर?
20350.
20350 ना?
350. हा, येस.
हा, ही आउटपुट पॉवर झाली. याच्यामध्ये लॉसेस मिक्स करा, दॅट इज इनपुट पॉवर मिळेल. दॅट इज पी इन इज इक्वल्स टू 20350 प्लस 2322. याच्यावरून पी इन मिळेल, दॅट इज इनपुट पॉवर. And once we got the input power and output power, then we are able to calculate the efficiency. So efficiency, it is equals to P out divided by P in into 100. So output power आहे 20350 divided by input power. किती येते?
89.75.
89.75. Okay, so efficiency it is equals to 89.75, or we can write it is 89.8% efficiency of the generator. Okay, see the problem, it is very easy but just lengthy, that means long process is there. If we go step by step, then it is very easy. First of all, calculate the losses of each and every machine, that is copper losses. After calculating copper losses, calculate the constant losses of the motor generator set. After that, calculate the constant losses of each machine, and after that calculate the efficiency of each machine. So just understand the procedure. After that it is very easy to solve. Okay, getting? Is there any doubt? कोणाला काही डाउट आहे का? Is there any doubt?
No, sir.
Okay. Can I give one example for homework?
Yes, sir.
Okay. Take a screenshot, all of you. याच्यामध्ये दोन्ही मशीनची इफिशियन्सी कॅल्क्युलेट करायची नाही. द मशीन हु इज रनिंग ॲज अ जनरेटर, वी वॉन्ट टू कॅल्क्युलेट द इफिशियन्सी ऑफ दॅट मशीन ऑल्सो. ओनली दॅट मशीनची इफिशियन्सी कॅल्क्युलेट करायची. ओके.